Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice using the Bonferroni test in conjunction with one-way ANOVA hypothesis testing. Let's get started. So, to run through this practice session in this mini lecture video, we're going to look at an example that we looked at in a previous mini lecture about arsenic and rice. So the arsenic came from 3 states. The arsenic was in the rice that came from 3 states, and they were Texas, Arkansas, and California. So to conduct the Bonferroni test here to identify which one is actually the one that's different from the rest, we need to conduct the Bonferroni test 3 times. So the hypothesis for our Bonferroni test: first, we think about the claim being made, which is usually just that everything's the same. That's going to then be our null hypothesis, because the null hypothesis is by definition a statement of equality. But we have to remember with Bonferroni that we're going to be writing a separate null hypothesis for each of the different pairings that we're going to be testing separately. The alternative hypothesis is then going to be the complement of the claim, which is that at least one of these means is different from the rest. So remember, with Bonferroni, we've got to write a separate null hypothesis because we're conducting a separate test with a different null hypothesis on an individual pairing. We don't have to do that with the alternative hypothesis because the alternative hypothesis is the same for all 3 of those tests that we're going to conduct. To get our Bonferroni test statistic, okay, it's tempting to go back to your ANOVA table and take that test statistic that's there, but you can't do that with Bonferroni. With Bonferroni, you got to calculate your own test statistic. So you can use the values that you get in your results tables there to get your calculation, but you've got to actually perform the calculation yourself by hand. So here's the equation you use. You substitute values in from your results window, and here's where those different values come from. So you just plug those into the proper place and calculate that out. In this case, it comes out to be 4.3998. So this is the test statistic for that first pairing between Texas and Arkansas. You're going to calculate a separate test statistic for each different pairing that you're actually going to compare and look at. So there's the test statistic for the first pairing, 4.3998. Then we can take that test statistic we just calculated to calculate out our p-value. Again, it's really tempting to just take that p-value from the ANOVA table, but that's not the one you want for Bonferroni. For Bonferroni, you've got to calculate your own. And we can do that by looking at the distribution calculator there in StatCrunch. So the p-value is still going to be the area bounded by the test statistic, but we've got to make an adjustment before we compare it with our significance level. So we've got 3 different possible pairings, so we're going to multiply that area that we get from our t-calculator out by 3. That represents the 3 different possible pairings that we're looking at. So we do that, we get 0.0002, which is the p-value we're going to use to compare with the significance level. Now we can decide whether to reject or fail to reject the null hypothesis. We have the same standard criteria that we've always had. So back here in our t-calculator, we take that area that comes out, which would be the p-value if we were only doing 1 pair, but now we're doing 3. So we're going to multiply by 3. And that gives us the p-value that we need to compare with our significance level of 5%. And we find that we're inside the region of rejection. So we reject the null hypothesis. If we want to use the critical value with the test statistic, we've got to make a similar adjustment, only we're going to divide instead of multiply. So back in our t-calculator, the area that we put in for the critical region is going to be 1/3 of our significance level. And that gives us a critical value of 2.22, which we then compare with the test statistic we calculated earlier. And we find that we're going to come to the same conclusion. We reject the null hypothesis. What then do we conclude from our hypothesis test? Well, remember with Bonferroni, it's a little different. We've got, we want to take answer option D. Okay, there is sufficient evidence to warrant rejection of the claim. We have sufficient evidence because we rejected the null hypothesis. We're rejecting the claim because, remember, we're using the p-value, which was actually computed with a two-tailed distribution. So we actually have a two-tailed test that we're running that way. And then the rest of the statement is just a rehash of the claim itself. So we rejected the null hypothesis. And the null hypothesis was that the two pairs that we looked at were the same. So we're rejecting that claim that each of those population means is the same. That means at least one of them is not the same. So of course, we've just done the test on one of the pairs. We've got two other pairs that we've got to repeat this test procedure with. So when we do that, here's the results that we come out with. So we saw these results earlier from what we just looked at with comparing the pair of Texas and Arkansas. It led us to reject the null hypothesis. That means that one of these two are different from each other. We run the same test with the other two pairings, and we find that we come to the same conclusion. So that means Arkansas and California are different from each other, and Texas and California are different from each other. Since we've got the same conclusion for each of our different pairings, that means all three population means are different from each other. This then is the statistical evidence we need to make the formal conclusion of which of the mean values is actually different. And in this case, it turns out to be all three of them. Now, supposing for a moment that the test here for Texas and California came out different. And it said that Texas and California, the conclusion you made here was fail to reject the null hypothesis. So now we've got a different conclusion. Here, if we would have said fail to reject the null hypothesis, that means the null hypothesis is true, and these two values are going to be the same. Texas is the same as California. That would then mean that Arkansas is the odd man out, because reject the null hypothesis says that Texas and Arkansas are different. Reject the null hypothesis here says Arkansas and California are different. So then if Texas and California are the same, that then means logically that Arkansas is the one that's different, and we'd have the statistical evidence then to say Arkansas is the one that's different. That's the one we need to focus on. Of course, we didn't actually get that conclusion. We got the conclusion here that we're rejecting the null hypothesis in all three pairings, so therefore all three of them are going to be different from each other. Informally, we could kind of get a sense of that if we go back to our results window from the one-way ANOVA test and look at the mean values here. You can see they're not really in the same neighborhood. None of the three are living in the same neighborhood, and so therefore you can kind of get a sense that all three of them, but again, this is an informal method. It doesn't provide formal statistical evidence to make a formal conclusion. That's why we do the Bonferroni test. And it's really involved because you got to separate out each individual pairing. So you can see that if you've got even just one more grouping, that the Bonferroni test gets really, really involved. But that's what you got to do if you need the formal evidence to identify which of those mean values is different from the rest. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.